Okay, we're trying that again. So, welcome to the Brampton Observatory channel. Uh, Tonight is today is International Astronomy Day, so I thought I'd do a brief broadcast here and see how it goes. Oop, there we go. So, we are live now. And I'm just going to go back to that. And today is International Astronomy Day, so I thought I'd do live broadcast. Didn't announce it in advance or anything like that, so anyone who watches it will probably watch it as a recorded on the YouTube channel. There are events going on across Canada and the United States and all around the world today for International Astronomy Day. Right now, the Royal Astronomical Society of Canada is broadcasting from across Canada, different locations, star parties and moon watching during the day. I know they had solar observatories going, or solar observing, I should say, going in a variety of different locations across Canada, and it's pretty exciting. So right now we're looking at across the terminator of the moon, which is why the moon is in shadow on one side and a little bit brighter on the other side. You can see how many craters are actually on the moon, and those craters represent meteor impacts. Some are quite large, others not so large. You can see a bit of a mountain range in the sort of the center there where the terminator is crossing, and a lot of dark areas on there as well. You can see off to the left on your screen some of the white ejecta from some of the impacts. Some of these impacts are millions and millions of years old. We know the moon, well, we theorize the moon was actually caused by a large planetary-like body colliding with the Earth billions of years ago, and the debris eventually coalesced together to form the moon. And we are going back to the moon. They're going to build this space station, which is really exciting, which is going to be sort of a stepping stone towards bigger missions like going to Mars and that sort of thing. Also planning on landing on the moon. A Canadian actually will be doing an orbit of the moon in the not too distant future, hopefully. These things are all scheduled, but we all know if you are into astronomy and space missions that sometimes these things are delayed for a variety of different reasons. The James Webb Space Telescope was a prime example of that. The JWST is finally launched. They've done, I think, the final calibrations on JWST. They're just doing some routine work with it now, and hopefully by July they'll actually be doing some hard science with it. There's been a lot of proposals for use of this telescope, which is different than the Hubble Space Telescope. The Hubble Space Telescope is for the most part, a visual telescope, where the JWST operates in the infrared, which allows us to see through the big gas lanes that exist in our galaxy and beyond. It'll also enable us to see very, very distant galaxies that have redshifted so much that they're no longer visually able to be seen, even through our biggest telescopes. And we're going to hopefully learn a lot about the universe, and especially the early universe, just after the Big Bang. And it's a really exciting time for astronomy and physics and science in general. A lot of things going on. And One day, who knows, maybe we'll have moon bases that are permanent. I mean, certainly that's in the plans, but again, unfortunately, sometimes plans change, and you're never quite sure which way governments and private industry, which seems to be the main driver these days of astronomy and exploration. SpaceX and others are actually now, for the most part, sending supplies to the International Space Station, which sadly will be decommissioned in the not too distant future. And hopefully the space station that will orbit the moon will be the next step in human exploration of our solar system, and eventually, hopefully, out to the stars. Maybe not in our lifetimes, but certainly we can dream about that. I'm going to shift the telescope a little bit now to see if we get another view here of the moon before we move on to other things. I'm going to do that slowly, but if I lose the moon, we will come back to it. So we're going to just shift it, up a little bit. So right now I'm just moving the telescope just little bits to see some different spots. Oops, didn't quite want to go that far. We're going to bring that back down. And we're just going in very small increments to see some of the more interesting detail. There we go. So that's kind of where we were before, a little lower. There we go. I want to come up just a bit. Slow that speed down a bit when we move. There we go. So now you can see just a slightly different perspective of the moon. We've moved down a little bit. Again, I apologize a little bit for the focus and the waviness, but again, as I said earlier on my first attempt at the broadcast, that's actually caused by a turbulent atmosphere, and there's really, from the point of view of where I am, not a lot I can do about that. I do have a light pollution filter attached to the telescope, I should say, right now, which helps to eliminate some of the light pollution that I get because I am in an urban area. Although I'm not in a downtown kind of urban area, I'm in a sort of a suburban north area of Brampton, near Caledon, which has slightly darker skies. I'm also cursed and lucky because I'm surrounded by houses, but they do block out some of the street lights and other light pollution that pops up during my observations. I do have some special filters like this light pollution filter that enable me to block out some of that ambient light that on occasion will come into play and kind of wash out your pictures. It's unfortunately fewer and fewer stars we're able to see in the night sky. Light pollution is a major problem. The RASC and other organizations are trying to educate cities and urban areas and even suburban areas on, how to put in place lighting that doesn't have the same effect on the night sky as other lighting situations do and other lighting products. That can sometimes be a large battle. People think a lot of light means safety. Well, it's actually been proven that a lot of light sometimes is not as safe as we would like it to be. I know they've done some tests where they had these bright lights, home security lights, and actually the tests they did, they were not able to see the simulated burglar clearly because on the cameras that they had, the security cameras, because the lights were so bright, it just washed them out. So I should mention the RASC, which is live broadcasting at this time as well. On YouTube. There are star parties going on all across Canada, as I mentioned earlier, and this is a day for astronomy. So we've had a look at the moon. I think it's probably dark enough now that we can move on to another target. So I'm going to show you a target that I actually have been working on imaging. We'll give it a whirl here, and we'll come off video for one thing. We'll go back to preview, and we're just going to do a quick image here of the moon, and it's just downloading. So I'm actually inside my control room. Oh, there we can see the moon. And that, of course, is very blown out because the moon is so bright. I'll try to bring that down a bit. And you get a big halo off it. This is shooting with a camera that's extremely sensitive to light on a telescope that is designed... Oh, there we go. That's a little better. On a telescope that's designed to take in as much light as it can. It's a f2 imaging telescope. It's only designed for imaging. You cannot, there is no eyepiece on this telescope. Very sadly, my imaging telescope, my 14-inch Celestron, I accidentally broke the corrector plate. It's in California right now with Celestron. I'm working on trying to get some funding together from my own way of doing things to fix it. It's an amazing instrument. I like the RASA 8, but the RASA 8 was really designed to take with me to dark sky sites and that sort of thing. It's a much smaller telescope and doesn't have the same capabilities. The 14-inch Celestron, I use what's called a Hyperstar, which is a special lens that goes on the front of the telescope that also makes it an imaging from the front telescope, and it also allows me to shoot at f2. So that, in quick terms, means more light in shorter amount of time reaches the sensor and the camera. So you don't have to take exposures that are as long as you would if you were just using it through a normal back end of, for instance, the 14-inch Celestron. I do hope, if people are watching this, that you will subscribe to my channel. We do live broadcast as much as we can. EAA, it's called, Electronically Assisted Astronomy. And we talk about space and the universe. So we're going to switch up targets now, so things are going to get a little wacky for a minute as the telescope slews over to a new target. We're going to actually go over to M82 and M81, which are two galaxies. So we're going to switch off the moon. We're going to go to M82. Where are you, M82? There you are. So this is also, as you can see on the screen, known as Bode's Nebulae, or Messier, which is what the M stands for. 82, Messier was an astronomer many moons ago, and he discovered a lot of these objects. So there's a whole catalog of objects under M, or Messier. And this one, because when these were discovered, they actually didn't know they were galaxies. At that time, it was really surmised that the only galaxy that was around was our own. So these were actually thought of as nebula or gas clouds within our own galaxy, which of course they're not. This is a completely different galaxy, and it's very, very far away. So we're just waiting for the telescope to track in here, which it should do soon. I'm actually using a hardware called an ASI Air Pro. Through the software that comes with it, it's doing all of this work through the telescope tracking and what's called go to telescope, so it's going to the objects that I select. If you do start taking up astronomy, I really suggest that you learn the night sky yourself. So do some star hopping and kind of get to know the sky. So detected a bunch of stars. It says we are centered on the target, so it's going to do a preview frame, which is going to look pretty bad. So we're going to do a longer exposure, obviously, than that. Oh, so there you kind of see, because I had it zoomed in, M82. So here we have two galaxies. I'm going to try to darken this up a wee bit here. This was a short 10-second exposure. That may be a little too dark for the screen. So you see a lot of stars in the background here. So we're going to do a much longer exposure than that. We're actually going to do a, let's do a 60-second exposure to start with. And we're going to start that. So these two galaxies, as I said, are actually about between 11 and 12 million light years away. And my wife is calling me. Talk about oddness. So I'm just going to mute myself for a minute. Where's my mute? Okay, sorry about that. Whoa. So what we had here was a complete blowout because we imaged a little longer, so we have to adjust what's called a histogram. And so the histogram just enables us to kind of preview and make things lighter and darker. Anyone who's done photography is familiar with histograms. So it just allows us to kind of preview it a little bit. And alright, let's zoom in a bit. So this is M82, or Bode's Nebula. From one image you really can't see, but there is, you can see a tiny bit. I'm not sure how visible it would be on the screen here. There is hydrogen clouds coming out of the top and the bottom. There's some really good images. So what I would do is take hundreds of images over a period of hours, stack all of them together, and then do noise reduction and some other processes on these galaxies that make it a very nice big picture. The preview screen here is a little smaller, so that's why I had to zoom in a bit. This galaxy years ago had a supernova that was visible, and it was somewhere right in around here, I believe, if you can see where I'm pointing to it. It really was a pretty significant event, and we have supernovas all the time, and there was another one of them just recently, actually. So let's have a look at M81. Again, this is a single image. It's not stacked, it's not prolonged. It's a 60-second shot, sub as we call them, but you can start to see the spiral arms of this galaxy. And again, once all of these images are stacked together, then it'll look completely different. You'll be able to see the spiral arms and everything else going on in there. So it's pretty amazing stuff to do. You can see these galaxies visually through a telescope. You will not see like this, and you certainly won't see what a finished image would look like from this perspective. You would see sort of a grayish smudge, quite small. There are some really neat things that you can look at visually, like the double cluster, some of the globular clusters, M13, M92, which are really fascinating. Unfortunately, I won't be able to do M13 at the moment. We're a little early in the season for where M13 is located for me, which if you look at my software here, you can see where this is like a special software. So this is actually my backyard. Don't mind the house cut off. I did that on purpose. And some of the trees. I do have a tree here that's quite tall, which makes polar alignment very difficult. Even though I'm on a pier, I do have to polar align once in a while. From spring through till late fall. In the wintertime, I can do it more because the leaves fall off. So hopefully my polar alignment will hold this year through the year. I actually have a pretty good polar alignment, which is really important to imaging because everything kind of rotates around Polaris here, which is basically the guide star. So you can see where M82 is located in the northern sky, just above Polaris. And you can start to see here, just above it is the Big Dipper. And so we're going to have a look now to see where M51 is, which is another galaxy called the Whirlpool Galaxy. Not sure if it's in view yet. It should be. So yeah, it's more out to the east. So we're going to change here and do M51. M51 is really a neat galaxy to look at. Unfortunately, Andromeda, which is the nearest galaxy to us that one day will actually collide with us, is not up in my area at the moment. So we're going to do M51, search, go to, you can see that's a Hubble picture of M51, the Whirlpool Galaxy. You can see it's a magnitude 8.4, so it's a fairly bright galaxy, but it is quite distant, so really you can view it with a telescope, put it that way, and visually if you know how and where to look. So let's go to M51. I'm going to let it do its thing. And there's some information about M51. Basically, it has different designations. It's also known as NGC, which stands for New Galactic Catalog 5194, and some other catalog names as well. It's a spiral galaxy. Its apparent magnitude is 8.60. Radial velocity, and basically it's transiting today at 1146. So hopefully we are, yeah, the telescope is auto-centering. And it's just loading again. It won't be much of an image yet. So you can't see anything yet because the histogram is set for different settings. So we're going to back that off a bit. Make sure we are centered. Okay, can kind of see it start to pop out in the background. You may not be able to see it yet on your screen. Oh, that's going to be way too dark. So I'm just going to zoom into it for a second because that was a 10-second shot. So here you can start to see, again, the whirlpool looks similar to that picture you saw earlier. So now we're going to do a much longer exposure on the whirlpool. And we're going to do, well, let's start with actually 120 seconds, so a 2-minute exposure on this one. This on my 14-inch telescope would be much larger in view and much brighter. That's again, I really miss that telescope. It has served me for many years and served me very well, so I'm really missing it, but hopefully I'll be able to get it functional again in the next few months. Unfortunately, these things do cost a lot of money to repair. I was shocked by the cost of the repair when I found out how much it was going to be, like almost $5,000 Canadian to repair it. It was a dumb mistake, my own fault that it got broken, but at the same time I was literally, much like the corrector plate, kind of shattered when I found out how expensive it was. So if you do have a higher end telescope, or even if you start out with a lower end telescope, make sure you look after your equipment well. It's really critical to keep it all in working order and be very careful with it. And I think I've told in one of my other videos the sad story of the squirrel in the telescope. So we're down to about 27 seconds now. Coming up on 20 seconds. And then we'll get a slightly, hopefully, better image. I'm going to end the broadcast in a little while because I do want to get some more images of both this galaxy and M82, and I don't want to bore you guys with hours of the same imaging. But we will get on. We have a whole week apparently of clear skies, so I'm going to try to do as much live stuff as I can as well, maybe every other day, again if conditions warrant. Oh, there we go. And I can see we had a slight tracking issue with the telescope there, so we're going to reshoot that. Sometimes the telescope mount is getting a little bit older and probably needs some maintenance, so sometimes it'll jerk just slightly and then you'll get a distorted image like I could see that image was. So what else have we got in here that we can take a look at before we close out tonight? We've got a whole lot of interesting things going on. Let's see, I think pretty sure M13 is not doable from my position. Yeah, M13 is actually quite low, and if you were to look at my neighbor's house, it's like literally maybe just above the roof. So maybe later on another night we'll be able to get that globular cluster. M92 I think is probably no better. Oops. Let's have a look at M92. Yeah, M92 is also maybe, yeah, it's about at the same level, which is interesting. So that probably is not the bestest of targets either. Again, it's quite early in the night, and we do have light from the moon that's causing a lot of astro imagers will not image during the during the full moon phase and some other phases of the moon because it washes out the sky to some degree. So if I were imaging over here in the same part of the sky as the moon, it would not go very well. Orion has already set, the Orion Nebula, so, well, below my horizon anyway. So, unfortunately, wouldn't be able to do much with that tonight either. I will come out with some other targets. Some of them require a filter change and go into the hydrogen alpha filter and H-beta filters that I have. By the way, all this grass you see here is long gone. I have the observatory built here now. So this is an older picture, which I should probably do a new one. But it works really fine. I'm using software that allows you to do that. It's called Starry Night Pro. It's great software. You can insert your own backyard. You just have to do a panorama 360 image. Just gives me perspective on where everything is in the sky. So let's have a look. That should have finished. Go to the histogram. And we're going to have to bring that way back because we did a longer image. And definitely it's looking like something has gone wacky with the mount. So yeah, you can see it's kind of doubled everything. I'm going to try it one more time. And sometimes the mount does that. I mean, I had a bunch of great nights where the mount was dead on, and on occasion it just gets wacky on you and starts slipping. It may be because I was doing manual tracking. I don't think it lost tracking. No, it's still tracking. But so this may be the last attempt here tonight. But it was great being live again for, well, it's been a while. And hopefully we'll get to be live a little more often. As I said, I would appreciate if you see this video, subscribing to the channel. And you can certainly ask questions as well when I'm on live. Or make comments about the channel if there's anything you'd like to see more of. If I can possibly do it, I certainly will. And I have a suspicion I'm going to have to reset my mount before I do my actual imaging. But interestingly enough, even with this picture, you can see more detail in the galaxy, and the satellite galaxy here as well. It doesn't look like this. This is caused by a tracking issue, so that it imaged here and then the image continues, and if I were to extend that even more, it would just continue. It's just basically copying the movement or tracking the movement of the galaxy, which means it's not tracking properly. And sometimes you have to do a restart on it, and then it's fine and it works well. And I suspect we are probably going to get the same thing again. We'll know in just a moment. It's just downloading the image. Oh, it didn't. So it's backtracking again. So that's good. We can kind of finish out the night with a decent image. I'm going to do one more, actually a 3-minute image, just to show you the difference. So this is zoomed in again if we were to go back. But this is once this image is processed, it's actually huge. It's 6,248 by 4,176. So this would be a very big image on a computer at full scale. This is not the actual scale that the final image would be. It would be more like this, only bigger, obviously. So let's just, for the fun of it, do 3-minute exposure. The tracking may go off again, I'm not sure. We'll find out. You can see some stars are actually pretty good in this part of the image. One of the issues I've been having is getting some eccentric stars, and here you can see it. Now I can fix this in the processing side, but this could be that my filter is just a little off, that it may not be quite attached, or my focus could be a little out, which I believe it probably is, and that's why you tend to get these stars that look stretched or eccentric a little bit as you come out. Some are more round, and it tends to be on the edges, and this in on other telescopes you would have a field flattener, which should help to alleviate that kind of problem, but on this one there's no field flattener. So I mean, I can fix this in PixInsight, which is a processing software, but for just live EAA here, there's nothing really I can do about it. But again, there's all kinds of things you have to learn if you do get into astro imaging. That's going to help you to make better images as you grow into the hobby. Don't expect to be getting the super images. If I go back, I was a visual astronomer for most of my life. Didn't do a lot of imaging. Got into imaging probably about 12 years ago, and some of my non-professional first images were absolutely horrible, but at the time I thought they were fantastic, and that's the key. If you like it, it's good. I used to get frustrated, and one other bit of advice, and I think I've given it in some of my other videos, you really can't buy yourself out of a problem in astronomy, at least not from the standpoint of beginner astronomy. So keep it in mind. Start slow, start small. You don't have to go out and drop tons of money on equipment. You can even use your iPhone these days to shoot stars, and some of the Samsung phones you can actually even do images something like this. Obviously not as good. This is using a dedicated astronomy camera. Alright, so it's going to download that image, and then we'll have a look at that and close out. That was a 3-minute exposure, so we'll see if it maintained the tracking or if it went wacky on me again. So it's going to blow it out a little bit because of the change of the length of the exposure. So we'll just bring that in a little bit. Yeah, that's starting to look a little sharper. Get rid of the histogram. Let's zoom in. So yeah, you can see quite a bit of detail now. For a single image, as I say, there would be hundreds of images stacked together, which would bring out a huge amount of detail and color. This is a single non-stacked image, and it's 180 seconds, so 3-minute exposure, which unlike my 14-inch, if I were not using the front-end camera, and the Hyperstar would be equivalent to like a 10 or 15 or more minute exposure to get the same data, which is the advantage of what's called an astrograph, which is the RASA telescope, which is strictly for imaging. It's very fast, and that has a lot of advantages, such as being able to get an image like this, one frame, very quickly. But it also has a lot of disadvantages, and those I'll talk about at another time. Anyway, I'm going to do some more imaging, and thank you for watching the International Day Astronomy broadcast here from the Brampton Observatory, and hopefully we'll be able to get on again through the week and get some more targets in. And like I said, if you subscribe to the channel, I would be very appreciative, as eventually maybe it'll help me pay for my broken telescope. Anyway, not likely. Alright, well, thank you, and remember, keep looking up and enjoy the night sky, because as time goes on, sadly, we are losing more and more of that night sky to light pollution. And join a local astronomy club. If you're here in Ontario, there's a variety of different RASC clubs, and like I belong to the Mississauga branch, and definitely anywhere in Canada, there's clubs right across Canada and chapters across Canada. So look them up on the internet, you'll find them, or go to the Royal Astronomical Society of Canada site, and it actually has a list of all of the chapters across Canada. Join that. There's a bunch of great people, and they do have outings and star parties and all kinds of great things going on. Happy International Astronomy Day, and have a great night.